Every comet we've ever studied follows predictable patterns. Ice sublimating into gas-trailing debris obeying the basic physics of our universe. Then 3 Atlas arrived and shattered every rule in the book, glowing ahead of itself instead of behind. No gas signatures, impossibly bright for its supposed size. The odds of such an object naturally occurring and finding us are virtually zero. But what if that's precisely the point? What if 3 Atlas is designed to be recognizably artificial, a cosmic calling card, testing whether humanity is intelligent enough to spot the obvious masquerading as the mundane? Tonight, we'll unravel why this mysterious visitor might be the ultimate Turing test, with humanity as the unknowing subject. Stay with me to the end. You'll never look at these interstellar anomalies the same way again. Now, prepare yourselves. We begin. Let me ask you this question. If humanity is not the examiner, but the examinee in a test of intelligence, would we realize it on July 1st, 2025? Astronomers discovered something impossible. An object designated 3 Atlas appeared in our telescopes, masquerading as a comet, yet defying every rule we've written about how comets behave. It glows ahead of itself rather than behind. It shows no trace of the water vapor or gas that should stream from any self-respecting chunk of ice. It arrived with timing so precise, a trajectory so calculated, that the odds of it being natural hover somewhere near mathematical impossibility. Yet our scientific establishment continues to call it a comet. This paradox brings us to a question that should make us uncomfortable. In 1950, Alan Turing proposed his famous test for artificial intelligence. Could a machine convince a human interrogator that it was human through conversation alone? The test wasn't really about the machine. It was about the human's ability to recognize intelligence when it hides behind familiar disguises. Now imagine that test scaled up. Not a computer pretending to be human, but an entire civilization pretending to be a rock. The question becomes, are we intelligent enough to recognize intelligence when it wears the mask of the ordinary? 3 Atlas forces this question upon us with uncomfortable urgency. If we fail to recognize what it truly represents, we risk being classified as not yet intelligent by observers who may be evaluating our species from across the cosmic dark. The stakes couldn't be higher. Our graduation into a larger galactic community may depend on whether we can solve this puzzle. History offers a sobering parallel. In 1794, Ernst Chladni dared to suggest that meteorites fell from outer space. The scientific community of his time found this notion so ridiculous that they ridiculed him mercilessly. Stones from space, preposterous. It took nearly a decade and thousands of witnesses to a meteorite fall in L'Aigle, France, before the establishment finally accepted what should have been obvious from the evidence. We like to think we've evolved since then, that we're more open to paradigm-shifting ideas. But are we? When presented with ʻOumuamua in 2017, an interstellar visitor that accelerated without any visible means of propulsion, we explained it away rather than seriously consider what it might represent. When 2020 SO fooled us completely, appearing natural until we realized it was actually human-made space junk, we learned the lesson that artificial objects can masquerade as natural ones. Yet somehow, this lesson evaporated when 3 Atlas arrived. The exhibits of evidence are mounting. Each misclassification, each dismissed anomaly, each comfortable explanation that doesn't quite fit the data. They form a pattern, a curriculum perhaps designed to test whether we possess the intellectual humility to question our assumptions when reality refuses to conform to them. Dr. Avi Loeb, the Harvard astrophysicist who has persistently championed alternative explanations for these cosmic anomalies, despite considerable professional pushback, represents something crucial in this narrative. He embodies the willingness to ask uncomfortable questions. to suggest that the emperor might indeed be wearing no clothes. His persistence in the face of establishment resistance echoes Chladni's lonely stand 2 centuries ago. But there's a difference this time. The clock is ticking. If 3 Atlas represents some form of evaluation, a cosmic midterm exam administered by intelligences we have yet to acknowledge, then our response reveals everything about our readiness to join a larger community of minds. Do we dismiss the anomalies because they threaten our comfortable worldview? Do we cling to explanations that require increasingly improbable coincidences? Or do we demonstrate the intellectual courage to consider possibilities that expand our understanding? The evidence suggests we're being tested on our ability to recognize the artificial hiding within the natural. Each interstellar visitor arrives with a slightly different disguise. A slightly more obvious contradiction between appearance and behavior. It's as if someone is gradually turning up the volume on a signal, waiting to see when we'll finally stop pretending we can't hear it. Consider the mathematical impossibility of 3 Atlas arrival, a retrograde trajectory aligned with our solar system's plane odds of 0.2%, perfectly timed encounters with Mars, Venus and Jupiter odds of 0.000005%, a brightness that suggests an object 20 kilometers across, so rare that we should see one, perhaps once every 10,000 years. These errant minor statistical quirks, they're astronomical red flags waving in a cosmic wind. Yet we continue to call it a comet. This cognitive dissonance reveals something profound about human nature. We are pattern-seeking creatures, but only for patterns that confirm what we already believe. When the universe presents us with patterns that challenge our paradigms, we often choose blindness over the discomfort of fundamental revision. The question that haunts this entire mystery is simple. If this is indeed a test, who sent it? And more unsettling still, are they still watching? The implications stretch beyond astronomy into the realm of existential reckoning. If we're being evaluated on our intelligence, our curiosity, our willingness to abandon comfortable assumptions, then our response to 3 Atlas becomes a mirror, reflecting our species' intellectual maturity. Are we ready to acknowledge that we might not be alone? Are we brave enough to consider that our cosmic neighbors might be far more subtle in their approaches than our science fiction has prepared us to expect? Can we admit that intelligence advanced enough to traverse interstellar space might also be sophisticated enough to design tests that challenge not just our knowledge but our wisdom? The story that follows will take you through the evidence piece by piece, anomaly by anomaly. We'll examine the history of humanity's struggle to recognize the extraordinary hiding within the ordinary. We'll explore the possibility that what we're witnessing isn't a series of coincidences, but a carefully orchestrated curriculum designed to measure our readiness for a larger truth. Prepare yourselves. We begin with the impossible object that started it all, the visitor that glows backwards and defies every natural law we thought we understood. But first, a warning. What you're about to hear will challenge everything you think you know about our place in the universe. The comfortable assumption that we're alone may not survive this investigation. The test has already begun. The only question is whether we're intelligent enough to recognize we're taking it. On July 1, 2025, the Hubble Space Telescope captured something that shouldn't exist. At first glance, 3 Atlas looked familiar enough. A fuzzy comet-like object drifting through our solar system. The initial images showed what appeared to be a standard cometary coma, that characteristic cloud of dust and debris that forms when ice sublimates. Astronomers around the world sighed with relief. Another cosmic visitor, certainly interesting, but nothing to lose sleep over. Then they looked closer. The dust plume wasn't where it should be. Instead of trailing behind the object, like the tail of every comet in human experience, this cloud preceded it. The object was glowing ahead of itself, as if some invisible force was stripping material from its leading edge. while leaving its trailing side pristine. This was impossible. Comets develop tails when solar radiation heats their ice, causing sublimation that creates the characteristic streaming effect away from the sunday. The physics are straightforward, predictable, textbook material. Yet here was an object that seemed to have read a different textbook entirely. The spectroscopic analysis that followed deepened the mystery. Every comet humanity has studied produces detectable signatures of water, vapor, and carbon monoxide, and various other gases as its ice sublimates. These molecular fingerprints are as fundamental to cometary identification as DNA is to biology. 3 Atlas showed none of them. 0 water vapor, no molecular signatures of the gases that should be streaming from any legitimate comet. It was glowing and producing a dust cloud without any of the chemical processes that should make it possible. The object's brightness presented another puzzle wrapped in statistical improbability. Based on its apparent magnitude, and assuming a typical comet's albedo, 3 Atlas would need to be approximately 20 kilometers across to produce the light we observed. Objects of this size arriving from interstellar space are extraordinarily rare. We should encounter one perhaps once every 10,000 years if current models are correct. What were the odds that such a statistical outlier would arrive during our brief window of observation? The mathematics were uncomfortable. Either we were witnessing a coincidence of astronomical proportions, or we were missing something fundamental about what we were looking at. The trajectory analysis revealed even more troubling anomalies. 3 Atlas was traveling on a retrograde orbit, moving backward relative to the general rotation of our solar system. This isn't impossible for natural objects, but it's unusual. More specifically, it's unusual to the tune of about 0.2% probability. But retrograde motion wasn't the only statistical red flag. The object's orbital plane was aligned almost perfectly with our solar system's ecliptic, the plane in which our planets orbit. For a truly random interstellar visitor, this alignment should occur with a probability of roughly 0.2%. Rare, but not impossible. The timing of its arrival, however, pushed the boundaries of statistical credibility beyond any reasonable breaking point. 3 Atlas would pass near Mars, then Venus, then Jupiter, in a sequence of planetary encounters choreographed with a precision that would make a celestial navigation computer jealous. The probability of such timing occurring by chance approximately 0.0000005%. Let's pause to consider what these numbers mean. We're not talking about a single unlikely event. We're talking about multiple independent improbabilities stacking atop each other. Like a house of cards built in a hurricane, each additional coincidence makes the natural explanation exponentially less likely. Yet the astronomical community's response was remarkably uniform. Comet, definitely a comet, unusual perhaps, but well within the bounds of natural variation. The anomalies were explained away with increasingly creative interpretations of sublimation physics. This response echoed through history with disturbing familiarity. In 1957, when Soviet engineers launched Sputnik 1, amateur radio operators around the world immediately recognized the artificial nature of its signals. The regular beeping pattern, the Doppler shift characteristics, the orbital parameters all screamed technology. But suppose Sputnik had been launched by a civilization with no radio communications. Those same radio operators might have heard the signals and dismissed them as atmospheric interference. Recognition of artificiality depends entirely on the observer's context, knowledge, and willingness to consider possibilities. The parallel with 3 Atlas is unsettling. We may be in the position of those hypothetical radio operators. Hearing signals, we lack the conceptual framework to properly interpret. The object arrives with characteristics that should trigger every alarm bell in our anomaly detection systems. Yet, we continue to force it into familiar categories, because the alternative genuine consideration that we might be observing technology feels too destabilizing. The mainstream scientific community's treatment of 3 Atlas reflects a peculiar form of intellectual conservatism. When confronted with data that doesn't fit established models, the tendency is to modify the data's interpretation rather than question the models themselves. The object must be a comet because comets are what we understand. The fact that it behaves nothing like any comet in our experience becomes a secondary concern, something to be explained away rather than explored. This approach works well for normal science, the steady accumulation of knowledge within established paradigms, but it fails spectacularly when reality refuses to cooperate with our expectations. History shows us that paradigm shifts require individuals willing to take anomalous data seriously, to consider the possibility that our fundamental assumptions might need revision. Dr. Avi Loeb emerged as one such voice in the 3 Atlas discussion. His suggestion that we should seriously consider artificial origins for the object was met with the kind of professional skepticism that has greeted paradigm-challenging ideas throughout history. Too speculative, too extraordinary, too far outside the bounds of respectable inquiry. But what if respectability is precisely the problem? What if our commitment to conventional explanations has blinded us to possibilities that should be obvious? The object that arrived on July 1, 2025 presents us with a choice between comfortable assumptions and uncomfortable evidence. The choice we make reveals everything about our readiness to recognize intelligence when it wears unfamiliar masks. If 3 Atlas represents some form of contact or evaluation, then our response becomes part of the data being collected. Are we a species capable of recognizing the artificial when it hides behind the apparently natural? Can we distinguish between what we want to be true and what the evidence actually suggests? The answers to these questions may determine whether we pass or fail whatever examination the universe has placed before us. The object that shouldn't exist continues its precisely choreographed dance through our solar system, glowing backwards and defying every natural explanation we've constructed to contain it. Whether we choose to see what it actually represents or continue insisting it must be something familiar and safe remains the test we're still taking. The results of that test may determine everything about our species' cosmic future. The year was 1794, and Ernst Chladni was about to commit intellectual suicide, standing before the European scientific establishment. This German physicist dared to suggest that meteorites, those strange iron-rich stones, had actually fallen from outer space. The response was swift and merciless ridicule, dismissal, professional ostracism. The very idea that stones could fall from the heavens violated every principle of rational thought. Where would they come from? How would they get there? The proposition was so absurd, it barely deserved refutation. For nearly a decade, Chladni's hypothesis languished in the realm of scientific heresy. Then on the 26th of April 1803, the sky exploded over L'Aigle, France. Thousands of witnesses watched a brilliant fireball streak across the afternoon sky before detonating. In the aftermath, investigators found the countryside littered with still warm stones. Stones bearing the unmistakable signatures of extraterrestrial origin. Jean-Baptiste Biot's subsequent investigation forced the European scientific community to confront an uncomfortable truth. Sometimes the impossible is merely the not yet understood. The stones did indeed fall from space, just as the ridiculed Chladni had claimed. Reality had refused to conform to professional expectations. This historical episode reveals a fundamental weakness in human cognition that we've never quite managed to overcome. When confronted with phenomena that challenge our established worldview, our first instinct is not curiosity, but dismissal. The anomaly must be wrong, the data must be flawed, the observer must be mistaken. Anything but the terrifying possibility that our carefully constructed understanding of reality might need revision. 2 centuries later, we find ourselves in a remarkably similar position. 3 Atlas presents us with data that defies comfortable explanation. Yet our scientific establishment responds with the same defensive reflexes that once rejected meteorites. The object must be a comet, regardless of how poorly it fits cometary behavior. Because comets are what we understand, and artificial probes are what we fear to consider. This pattern of denial repeats throughout scientific history with disturbing regularity. Ignaz Semmelweis discovered that hand-washing dramatically reduced mortality rates in maternity wards, only to be ridiculed and eventually driven to madness by colleagues who couldn't accept that their unwashed hands were killing patients. Alfred Wegener proposed continental drift decades before plate tectonics became accepted theory, enduring professional marginalization for suggesting that continents could move. The pattern is always the same. Anomalous data challenges an established paradigm. The establishment ridicules and dismisses the challenger. Reality eventually forces acceptance of the new understanding. The only variable is how long it takes for cognitive inertia to finally surrender to evidence. But there's something particularly troubling about our current situation with 3 Atlas. Unlike Chladni's meteorites or Wegener's drifting continents, this anomaly comes with a ticking clock. If the object represents some form of evaluation or contact attempt, then our window for appropriate response may be limited. We might not have decades to gradually overcome our professional prejudices. The mathematics of 3 Atlas arrival should make any rational observer profoundly uncomfortable. The probability calculations don't merely suggest improbability, they scream impossibility. Yet we continue to invoke increasingly creative explanations to maintain our comfort zone, rather than seriously consider the obvious alternative. It's like watching someone refuse to believe lightning is electricity, because they're not ready to accept that the sky can generate power. The evidence is undeniable, the phenomena repeatable and measurable. Yet cognitive inertia prevents a paradigm shift until someone finally dares to fly a kite in a thunderstorm. Benjamin Franklin's electrical experiments provide another useful parallel. When he proposed that lightning and laboratory electrical sparks were manifestations of the same force, the European scientific establishment was skeptical. Electricity was a parlor trick. Lightning was a meteorological phenomenon. The two couldn't possibly be related. Franklin's kite experiment changed everything by demonstrating that anomalous data properly interpreted could reveal fundamental truths about the nature of reality. The key was his willingness to take the anomaly seriously rather than explain it away. Today's astronomers studying 3 Atlas face their own kite in a thunderstorm moment. They can continue invoking increasingly improbable natural explanations, or they can demonstrate the intellectual courage to consider what the evidence actually suggests. The choice they make will determine whether we repeat the historical pattern of delayed recognition or finally learn to embrace anomalies as opportunities for paradigm expansion. The stakes extend far beyond professional reputations or scientific careers. If we're being evaluated on our ability to recognize intelligence when it disguises itself as familiar phenomena, then our treatment of 3 Atlas becomes a test of our species' intellectual maturity. Are we capable of learning from historical mistakes, or are we doomed to repeat them even when cosmic contact might hang in the balance? The tragedy of scientific conservatism is that it often delays exactly the kind of breakthrough thinking, the kind that genuine anomalies demand. When reality presents us with data that doesn't fit our models, the rational response should be excitement, not defensive dismissal. Anomalies are gifts, opportunities to discover something genuinely new about how the universe works. Yet our institutional structures reward conformity and punish speculation. Graduate students learn quickly that career advancement depends on working within established paradigms, not challenging them. Senior researchers protect their reputations by avoiding controversial interpretations, even when those interpretations might be correct. This creates a systemic blindness to genuinely revolutionary possibilities. We've constructed a scientific culture that excels at normal science, the steady accumulation of knowledge within accepted frameworks, but struggles with paradigm shifts that require fundamental reconceptualization. The historical record suggests that major breakthroughs often come from outsiders, individuals with less investment in maintaining established paradigms and more freedom to consider uncomfortable possibilities. Chladni was a physicist studying acoustic patterns when he proposed extraterrestrial meteorites. Franklin was a printer and diplomat when he revolutionized electrical theory. Sometimes the most important insights come from those least committed to conventional wisdom. Dr. Avi Loeb's role in the Three Atlas controversy fits this historical pattern perfectly. His willingness to suggest artificial origins for anomalous interstellar objects represents exactly the kind of paradigm-challenging speculation that drives scientific progress forward. Yet his ideas are dismissed by colleagues who seem more invested in maintaining professional respectability than exploring uncomfortable possibilities. The question facing us today is whether we can learn from historical mistakes or whether we're destined to repeat them. Will 3 Atlas become another elagical meteorite fall, an obvious truth that takes years to accept? Or can we demonstrate the intellectual evolution necessary to recognize intelligence when it presents itself in unfamiliar forms? History itself has become our examiner, testing whether we've developed the cognitive flexibility necessary to handle genuinely paradigm-shifting discoveries. The answer may determine not just our scientific progress, but our readiness for contact with forms of intelligence that have learned to communicate in ways we haven't yet imagined. The rocks are still falling from the sky, but now they're falling from between the stars. Whether we choose to see them as stones or signals may be the most important decision our species makes in the coming years. The test continues and the clock keeps ticking. The 19th of October, 2017, the Pan-STARRS telescope in Hawaii detected something unprecedented. The first confirmed interstellar visitor to our solar system. Scientists designated it ʻOumuamua, using the Hawaiian term for messenger from afar arriving first. The name proved more prophetic than anyone initially realized. ʻOumuamua was unlike anything in our catalogues of celestial objects. Most asteroids and comets are roughly spherical, or at least chunky and irregular. This visitor was elongated to an extraordinary degree, shaped like a cigar or possibly a pancake, with length to width ratios between 5:1 and 10:1. Nothing in our solar system exhibits such extreme proportions, but the shape was merely the beginning of the mystery. As ʻOumuamua rounded the Sun and began its journey back toward interstellar space, it displayed behavior that violated every law of celestial mechanics. The object was accelerating away from the Sun faster than gravity alone could account for. Something was pushing it, providing additional momentum that our models couldn't explain. When comets exhibit non-gravitational acceleration, the explanation is straightforward. Ice sublimates in solar heat, creating jets of gas that act as natural rocket engines. The phenomenon is well understood, predictable, and accompanied by characteristic spectroscopic signatures. ʻOumuamua showed none of these signatures. No water vapor, no gases, no visible cometary tail. Yet it was accelerating as if propelled by forces that remained completely invisible to our instruments. The astronomical community faced an uncomfortable choice. Either ʻOumuamua represented a completely new type of natural object, something never before seen in billions of years of solar system evolution, or it was something artificial, something manufactured rather than accreted from cosmic dust and ice. Dr. Avi Loeb, Harvard's chairman of astronomy at the time, dared to voice what others were thinking. What if ʻOumuamua was artificial? What if its unusual acceleration came not from sublimating ice, but from radiation pressure, acting on a constructed surface perhaps a solar sail or similar technology. The suggestion ignited fierce debate within the astronomical community. Loeb's solar sail hypothesis was dismissed as speculative, extraordinary, insufficiently grounded in conventional astrophysics. The object had to be natural because artificial alternatives were too uncomfortable to seriously consider. Yet, the evidence continued to resist natural explanations. ʻOumuamua's rotation was chaotic, tumbling end over end in a way that suggested either a highly irregular shape or some form of structural damage. Its surface reflectivity varied dramatically as it tumbled, hinting at a composition or construction unlike any known natural body. Most troubling of all was the object's trajectory analysis. Working backward from its observed path, astronomers determined something. ʻOumuamua had been traveling through space for millions of years before arriving in our solar system. It hadn't originated from any nearby star system, hadn't been ejected from any identifiable source. It was genuinely nomadic, wandering between the stars with no clear origin point. This background makes the solar sail hypothesis particularly intriguing. An artificial probe designed for long-duration interstellar travel would need exactly these characteristics: extreme structural efficiency, leading to unusual proportions, radiation pressure, propulsion, eliminating the need for fuel, and autonomous navigation, capable of course corrections during million-year journeys. The parallels with human technology are striking. In 2020, our own spacecraft 2020 SO was initially classified as an asteroid. When ground-based telescopes first detected it, only detailed analysis revealed it was actually a Centaur rocket stage from a 1966 lunar mission, still orbiting the Sun after decades in space. The misidentification of 2020 SO demonstrates how easily artificial objects can masquerade as natural ones, even when we know the technology involved and have detailed records of its launch. If human-made space debris can fool our detection systems, how much more easily might technology from an advanced civilization escape recognition? This precedent makes ʻOumuamua's case even more compelling. We've proven that artificial objects can be mistaken for natural ones. We've demonstrated that even our own technology can fool our classification systems. Yet, when confronted with an interstellar visitor displaying clearly artificial characteristics, we reflexively assume it must be natural because the alternative challenges too many assumptions. The Tesla Roadster provides another instructive parallel. When SpaceX launched Elon Musk's car into space in 2018, it briefly appeared on asteroid detection networks as an unknown object. Observers who didn't know about the launch would have classified it as space debris or possibly a small asteroid. Only contextual knowledge revealed its true nature. These examples illustrate a fundamental blind spot in our approach to anomalous objects. We're remarkably skilled at recognizing our own technology in space, but completely unprepared to identify technology that doesn't match our current capabilities or design philosophies. An advanced civilization's probes might be as invisible to us as our smartphones would be to observers from the 18th century. The technology gap could render their artifacts literally incomprehensible, forcing us to categorize them as natural phenomena because we lack the conceptual framework to recognize their artificial nature. The solar radiation pressure connection between 2020 SO and ʻOumuamua is particularly troubling for conventional explanations. If human rocket stages can exhibit non-gravitational acceleration through radiation pressure alone, why do we continue to insist that ʻOumuamua's similar behavior must indicate some exotic form of natural sublimation? The answer reveals more about human psychology than astrophysics. We're comfortable accepting radiation pressure as an explanation when the object is recognizably human-made, but deeply uncomfortable applying the same physics to objects that might indicate non-human technology. The cognitive dissonance forces us into increasingly creative natural explanations, rather than acknowledging the obvious artificial alternative. This pattern of selective physics application represents a profound failure of intellectual consistency. Either radiation pressure can produce the observed acceleration profiles, or it cannot. The origin of the accelerating object shouldn't determine which physical laws we're willing to invoke. Yet somehow it does. The Tesla Roadster and 2020 SO also demonstrate how quickly our own technology can become archaeologically interesting. Both objects will survive in space for millions of years, potentially outlasting human civilization itself. Future observers, whether human descendants or alien visitors, might discover these artifacts long after their origins have been forgotten. Imagine the interpretive challenges such discoveries might pose. A future xenoarchaeologist finding a fossilized Tesla Roadster might puzzle over its purpose, its creators, its significance to the civilization that launched it. The spacesuited mannequin, the radio playing David Bowie, the cherry red paint job, all would be clues to decode a vanished culture's values, technology, and sense of humor. This archaeological perspective adds another layer to the ʻOumuamua and Free Atlas mysteries. If these objects are indeed artificial, they might represent archaeological artifacts from civilizations far older than our own. Their creators might be extinct, leaving behind only these wandering monuments to vanished technological achievements. Or they might be very much alive, watching to see how we interpret the clues they've left for us to find. The false alarms teach us that space is already full of artificial objects masquerading as natural ones. Our own technology joins the cosmic masquerade, tumbling through orbits that will persist long after we've forgotten launching it. In this context, the arrival of genuinely anomalous interstellar visitors becomes less about whether artificial objects exist in space. We know they do, and more about whether we're intellectually honest enough to recognize artificiality when it doesn't bear obvious human fingerprints. The tests continue, each one slightly more challenging than the last. First came ʻOumuamua, with its impossible acceleration and no natural explanation. Then came our own technology fooling us completely, proving that artificial can indeed masquerade as natural. Now Free Atlas arrives with anomalies so pronounced that even our creative explaining away mechanisms struggle to contain them. Each false alarm has been a lesson in humility, a reminder that our detection systems are fallible and our interpretive frameworks incomplete. The question is whether we're learning from these lessons, or simply repeating the same mistakes with increasing stubbornness. The universe appears to be running a curriculum designed to test our ability to distinguish between the artificial and the natural when the stakes are highest. So far, we're achieving passing grades on the practice questions, eventually recognizing our own technology, eventually acknowledging when we've been fooled. But the final exam may have already begun. And unlike the practice questions, this time we might not get the answers until it's too late to change our score. Let's dissect the impossible. Free Atlas presents us with a collection of anomalies so pronounced that each one considered individually challenges our understanding of how natural objects behave in space. Taken together, they form a pattern that stretches coincidence theory beyond any reasonable breaking point. Begin with the backwards glow. Every comet in human experience develops its characteristic tail through a straightforward physical process. Solar radiation heats the nucleus, ice sublimates into gas, and radiation pressure plus the solar wind sweep the resulting material away from the sunday. The tail always points away from our star, never toward it, never ahead of the object's motion. Free Atlas glows in precisely the wrong direction. Its dust plume precedes it through space like a cosmic headlight, illuminating its path rather than marking where it's been. This isn't a minor observational quirk, it's a fundamental violation of cometary physics that requires entirely new theoretical frameworks to explain. The most charitable interpretation involves exotic sublimation mechanics, that somehow concentrate material ejection on the object's leading edge, while leaving its trailing surface inactive. But this explanation requires atmospheric dynamics unlike anything observed in our solar system, operating under conditions that exist nowhere in our models of cometary behavior. The spectroscopic silence deepens the mystery. Free Atlas produces its anomalous dust plume without any detectable signatures of the gases that should accompany such activity. No water vapor, despite ice supposedly sublimating to create the observed effects. No carbon monoxide, despite models requiring such compounds to explain the object's behavior. No molecular fingerprints of any kind that would confirm the natural processes allegedly at work. This absence of chemical signatures isn't simply unusual, it's physically impossible under conventional cometary theory. You cannot have sublimation without molecular byproducts. You cannot have dust ejection without the gas dynamics that create and propel such ejection. Yet 3 Atlas manages both impossibilities simultaneously. The size implications create their own statistical nightmare. Based on the object's brightness and assuming typical cometary albedo values, 3 Atlas would need to measure approximately 20 kilometers across. To produce the light curve we observe, objects of this magnitude arriving from interstellar space represent statistical unicorns. We should encounter one perhaps once every 10,000 years. What are the odds that such an extraordinarily rare visitor would arrive during the narrow window of human technological capability to detect and analyze it? Our species has possessed the instruments necessary to study interstellar objects for perhaps 50 years, out of the hundreds of thousands of years we've existed. The timing alone suggests either impossible coincidence or deliberate intent. But timing represents only one layer of the statistical impossibility lasagna that 3 Atlas serves up. The object's trajectory reads like a navigation computer's dream route through our solar system. Its path will bring it into gravitational interaction with Mars, then Venus, then Jupiter, in a sequence so precisely choreographed that NASA mission planners would weep with envy. The probability of such planetary encounters occurring by chance, roughly 0.0000005%. To put this in perspective, imagine throwing a dart at a map of the United States while blindfolded, and hitting not just a specific city, but a specific building on a specific floor in a specific room. The mathematical odds of 3 Atlas arrival parameters occurring naturally are comparable to such impossible accuracy. Yet we continue to invoke coincidence as an explanation. The retrograde orbital alignment adds another layer of improbability. 3 Atlas travels backward relative to our solar system's general rotation, while maintaining near-perfect alignment with our orbital plane. Natural interstellar visitors should arrive from random directions with random orientations. The odds of achieving 3 Atlas-specific combination of trajectory parameters, approximately 0.2% for the retrograde motion, 0.2% for the plane alignment, and 0.00005% for the planetary encounter timing. These aren't cumulative probabilities, they're multiplicative. Each independent improbability makes the natural explanation exponentially less likely. We're not dealing with a single statistical outlier, but with multiple independent impossibilities stacking atop each other like cosmic Russian dolls. The dust dynamics present their own physics puzzles. Computer models attempting to explain 3 Atlas behavior require the object to shed a surface layer of millimeter-thick dust over approximately 6 months. This shedding must occur preferentially on the leading edge, while leaving the trailing surface relatively intact, a process that has no known analog in cometary science. Moreover, the dust production must continue without any of the sublimation signatures that drive such processes. We're asked to believe in dust ejection without gas dynamics, surface erosion without chemical weathering, and sustained activity, without the energy sources that power such phenomena. The albedo assumptions underlying the 20-kilometer size estimate create their own interpretive challenges. If 3 Atlas reflects light more efficiently than typical comets, if its surface is more mirror-like than the charcoal black nuclei we're accustomed to studying, then the object could be significantly smaller while producing the same brightness we observe. A highly reflective surface would be entirely consistent with technological origins. Manufactured materials often exhibit albedo values much higher than natural space rocks, particularly if designed for specific optical or thermal properties. But acknowledging this possibility requires abandoning comfortable assumptions about what we're looking at. The temporal synchronization of 3 Atlas arrival with humanity's technological maturation raises questions that extend far beyond astrophysics into the realm of cosmic sociology. Why now? Why during the brief historical moment when our species has developed the capabilities necessary to detect, track, and analyze interstellar visitors? If the object represents a natural phenomenon, its timing is simply another impossible coincidence. But if it represents something else, a contact attempt, an evaluation protocol, an archaeological survey, then its arrival precisely when we're capable of recognizing it suggests intention rather than accident. The mathematical realities are unavoidable. Each anomaly considered individually strains natural explanation. Considered together, they demolish it. We're left with a choice between invoking increasingly improbable coincidences or acknowledging the obvious alternative that our comfort zones prevent us from seriously considering. Imagine discovering a chessboard in the wilderness with pieces arranged in complex mid-game positions. You could invoke wind patterns, animal interference, and random chance to explain how it happened. But at some point, the accumulation of improbabilities forces a simpler conclusion: someone played chess here. 3 Atlas presents us with the cosmic equivalent of that wilderness chessboard. Every piece positioned with impossible precision. Every parameter calibrated to mathematical perfection. Every characteristic designed to challenge our assumptions about what constitutes natural behavior in space. The question isn't whether the anomalies exist. They're documented, measured, undeniable. The question is whether we possess the intellectual honesty to acknowledge what they collectively represent, or whether we'll continue explaining away each impossible coincidence until the opportunity for appropriate response has passed. The anatomy of this anomaly reveals not just the limits of natural explanation, but the limits of our willingness to consider alternatives that expand our understanding. We stand before a cosmic riddle that may determine our species' readiness for a larger conversation, and our response reveals everything about whether we deserve to participate in that conversation. The object continues its impossible journey through our solar system, glowing backwards and defying physics with each passing day. Whether we choose to see what it actually represents or continue insisting it must be something familiar and safe remains the test we're still failing to pass. In 1950, Alan Turing posed a deceptively simple question, a question that would revolutionize our understanding of intelligence. Could a machine convince a human interrogator that it was human through conversation alone? The test wasn't really about the machine's capabilities. It was about the human's ability to recognize intelligence when it hides behind convincing mimicry. Now scale that test to cosmic proportions. What if advanced civilizations use a similar evaluation protocol to assess emerging species like humanity? What if they send probes disguised as natural objects to test whether we possess the intellectual sophistication necessary to recognize artificial intelligence when it masquerades as familiar phenomena? This is the alien Turing test hypothesis, and 3 Atlas may represent its most sophisticated implementation yet. The concept is elegantly subversive. Rather than announcing themselves with obvious displays of technology that might contaminate or destabilize developing civilization, Advanced species could evaluate our readiness for contact through carefully designed ambiguities, objects that could be interpreted as either natural or artificial. Depending on the observer's sophistication and willingness to consider uncomfortable possibilities, the test isn't whether we can detect advanced technology when it announces itself. Obviously, that would be trivial. The test is whether we can recognize intelligence when it deliberately hides behind the mask of the ordinary. The natural, the easily dismissed. Comets make perfect disguises for such evaluations. They're familiar enough to trigger comfortable explanations, yet variable enough to accommodate significant anomalies without immediately screaming artificial. An advanced probe designed to mimic cometary behavior while subtly violating natural laws would force observers to choose between intellectual comfort and intellectual honesty. The curriculum appears to be escalating in difficulty. ʻOumuamua arrived in 2017 as a moderately challenging test case. Strange enough to intrigue, ambiguous enough to dismiss. Its non-gravitational acceleration could be explained away with creative physics. Its unusual shape rationalized through unlikely but theoretically possible formation scenarios. We could maintain a comfortable distance from paradigm-threatening interpretations, while still engaging with genuinely anomalous data. Human technology inadvertently provided the next lesson. The Tesla Roadster and 2020 ESO demonstrated how easily artificial objects masquerade as natural ones, how radiation pressure can produce precisely the acceleration characteristics that made ʻOumuamua so mysterious. These weren't planned elements of any alien curriculum, but they served as perfect preparatory exercises for what was coming. Now 3 Atlas arrives as what may be the final examination. Its anomalies are so pronounced, its statistical impossibilities so blatant, that explaining it away requires intellectual gymnastics that would make Olympic contortionists envious. The backwards glow, the missing molecular signatures, the mathematically impossible trajectory timing, each represents a cosmic red flag waving in an increasingly strong breeze. Yet, we continue to ignore the flags. This persistence in comfortable interpretation, despite mounting evidence, suggests something. That the test is measuring more than our scientific capabilities. It's evaluating our psychological readiness for paradigm shift, our willingness to abandon familiar assumptions when reality refuses to cooperate with them. The timing of these visits supports the evaluation hypothesis. ʻOumuamua arrived just as humanity developed serious capabilities for interstellar object detection. 3 Atlas appears precisely when our instruments are sophisticated enough to document its impossibilities. If these were random natural visitors, such timing would represent yet another statistical miracle. But if they represent elements of a designed curriculum, the timing becomes perfectly logical. Each test arrives exactly when we're capable of taking it, challenging us to demonstrate an intellectual growth commensurate with our technological advancement. The escalating difficulty curve resembles educational psychology more than cosmic coincidence. Basic concepts, first followed by increasingly complex applications, culminating in comprehensive examinations that test not just knowledge, but wisdom. The pattern suggests pedagogical intent rather than random occurrence. Consider the psychological sophistication required to design such a test. The evaluators would need to understand human cognitive biases, our tendency to dismiss anomalies rather than revise worldviews, our professional incentive structures that reward conformity over paradigm-challenging speculation. They would need to calibrate each test case to maximize the tension between evidence and comfort zone. This level of psychological insight implies long-term observation of human behavior patterns. We may have been studied far longer than we've been capable of studying ourselves. Our cognitive strengths and weaknesses, our cultural biases, our institutional structures, all mapped with scientific precision by intelligences that understand us better than we understand ourselves. The stakes embedded in this evaluation protocol extend far beyond academic interest. Success or failure in recognizing artificial intelligence disguised as natural phenomena could determine our species' readiness for direct contact, our qualification for membership in whatever galactic community might exist among the stars. Failure would mark us as intellectually immature, too cognitively rigid to handle contact with genuinely advanced civilizations. Success would demonstrate the intellectual humility and paradigm flexibility necessary for productive interaction with forms of intelligence that operate on principles we haven't yet discovered. The evaluation criteria seem designed to test specifically the qualities that genuine scientific progress requires. Can we abandon comfortable assumptions when presented with contradictory evidence? Do we possess the intellectual courage to consider possibilities that threaten established paradigms? Are we capable of learning from anomalies rather than simply explaining them away? These are precisely the characteristics that separate genuine scientists from mere technicians, genuine thinkers from mere information processors. The alien Turing test measures not our computational capabilities or instrumental sophistication, but our wisdom, our intellectual maturity, our readiness to engage with realities larger than our current understanding. The observers conducting this evaluation remain invisible, their presence revealed only through the impossibilities they scatter across our solar system. They watch our response to each test case, documenting our choices between evidence and comfort, between curiosity and defensiveness. Dr. Loeb's persistent advocacy for artificial explanations represents exactly the kind of response the evaluation might be designed to elicit. His willingness to consider uncomfortable possibilities despite professional pushback demonstrates the intellectual courage that advanced civilizations might be seeking in potential contact partners. Conversely, the mainstream astronomical community's reflexive dismissal of artificial hypotheses might represent precisely the cognitive rigidity that would disqualify a species from galactic citizenship. The unwillingness to seriously consider evidence that challenges comfortable assumptions reveals exactly the kind of intellectual immaturity that advanced observers would need to identify. The test continues with each passing day that 3 Atlas maintains its impossible behavior. Every attempt to force its characteristics into natural categories, every creative explanation that requires increasingly improbable coincidences, every dismissal of obvious artificial alternatives all become data points in an evaluation we may not realize we're taking. The ultimate irony is that our awareness of the test's existence might itself be part of the evaluation. Are we capable of recognizing when we're being evaluated? Can we acknowledge the possibility that our cosmic behavior is being observed and judged by intelligences far more advanced? The alien Turing test hypothesis transforms 3 Atlas from a mere astronomical curiosity into an existential examination. Our response reveals not just our scientific sophistication, but our species' readiness for a larger cosmic conversation. Whether we pass or fail this examination may determine whether that conversation ever has the opportunity to begin. The observers remain silent, watching, waiting to see whether humanity demonstrates the intellectual evolution necessary to recognize intelligence when it chooses to reveal itself through subtle impossibilities rather than obvious displays. The results of their evaluation may determine everything about our species' cosmic future. The test is already underway. The question is whether we're intelligent enough to realize we're taking it. Nonsense on stilts, declared Professor Chris Lintott of Oxford University. When confronted with suggestions that 3 Atlas might represent something other than a natural comet, his dismissal, delivered with the authority of institutional astronomy, captured the emotional undercurrent running through much of the scientific establishment's response. But notice something crucial about that phrase, nonsense on stilts. It's not a scientific argument. It's not an analysis of evidence or a careful weighing of probabilities. It's a rhetorical weapon designed to shame rather than illuminate, to shut down discussion rather than advance it. This kind of response reveals far more about the psychology of scientific institutions than about the objects those institutions claim to study. When confronted with genuinely paradigm-challenging data, the human tendency is not dispassionate analysis, but emotional defense. Careers, reputations, entire worldviews become invested in maintaining existing interpretations, regardless of how poorly they fit emerging evidence. The institutional structures of science, designed to promote careful inquiry, can become obstacles to the very paradigm shifts they should facilitate. Dr. Lintot's dismissal was echoed throughout the astronomical community, with variations on the same theme. Extraordinary claims require extraordinary evidence became the rallying cry, as if the mathematical impossibilities surrounding 3 Atlas somehow failed to meet extraordinary standards. The phrase, originally intended to promote scientific rigor, had been weaponized to dismiss any interpretation that threatened comfortable assumptions. But what constitutes extraordinary evidence when the ordinary evidence already defies ordinary explanation, when the statistical odds of natural occurrence approach mathematical impossibility? At what point does continued insistence on natural origins become more extraordinary than artificial alternatives? The resistance pattern follows historical precedent with depressing predictability. When Alfred Wegener proposed continental drift in 1912, the geological establishment didn't counter with careful analysis of his evidence. They ridiculed the very suggestion that continents could move. The mockery continued for decades until plate tectonics finally forced acceptance of ideas that should have been obvious from the data. When Ignaz Semmelweis demonstrated that hand-washing dramatically reduced mortality rates in maternity wards, the medical establishment didn't celebrate the discovery. They destroyed the messenger. Semmelweis was eventually driven to madness by colleagues who couldn't accept that their unwashed hands were killing patients. The pattern is always the same. Paradigm-threatening evidence appears. The establishment ridicules and dismisses the evidence. Reality eventually forces acceptance of the new understanding. The only variable is how much time, energy, and human suffering gets wasted during the resistance phase. But there's something particularly troubling about our current resistance to the 3 Atlas anomalies. Unlike continental drift or germ theory, this situation comes with a ticking clock. If the object represents some form of evaluation or contact attempt, then our window for appropriate response may be limited. We might not have decades to gradually overcome our professional prejudices. The emotional intensity of the resistance suggests that more than scientific paradigms are at stake. The possibility that 3 Atlas might be artificial touches on fundamental questions about humanity's place in the universe, our uniqueness as intelligent beings, our readiness for contact with forms of intelligence that surpass our own capabilities. These existential anxieties manifest as a fierce defense of familiar interpretations, even when those interpretations require increasingly creative explanations to accommodate the data. It's psychologically easier to invoke multiple independent impossibilities than to acknowledge the single obvious possibility that threatens our cosmic loneliness. The sociology of scientific consensus becomes a hidden variable in paradigm evaluation. Graduate students learn quickly that career advancement depends on working within established frameworks, not challenging them. Tenure-track professors understand that controversial interpretations can derail promotion prospects. Senior researchers protect their reputations by avoiding speculative hypotheses, even when those hypotheses might be correct. This creates a systematic pressure toward intellectual conformity. That has nothing to do with evidence, quality, or logical reasoning. The most paradigm-threatening ideas often come from outsiders. individuals with less investment in maintaining established interpretations, and more freedom to consider uncomfortable possibilities. Dr. A.V. Loeb's role in the Three Atlas controversy exemplifies this pattern perfectly. His tenured position at Harvard provides sufficient security to consider hypotheses that might destroy the careers of less established researchers. His willingness to suggest artificial origins for anomalous objects represents exactly the kind of intellectual courage that paradigm shifts require. But institutionnelle structure discourage. The backlash against Loeb's interpretations reveals the emotional stakes embedded in these discussions. Critics don't simply disagree with his analysis. They question his scientific judgment, his professional competence, his right to serious consideration. The personal attacks suggest that more than astronomy is being defended, what's being protected is an entire worldview built on the assumption that intelligence is rare, that technology is primitive, that the universe consists primarily of rocks and gas with occasional natural phenomena. The possibility that intelligence might be common, that technology might be subtle, that the universe might be full of observers we haven't learned to recognize, represents a fundamental threat to anthropocentric assumptions. This psychological investment in familiar interpretations creates a kind of institutional blindness to genuinely revolutionary possibilities. The very mechanisms designed to protect science from error can become obstacles to accepting truths that require paradigm revision. The irony is that skepticism properly applied should lead toward artificial explanations for Three Atlas, when natural explanations require multiple independent impossibilities, while artificial alternatives require only the existence of intelligence elsewhere in the universe. Genuine skepticism should favor the simpler hypothesis, but institutional skepticism has become selectively applied. We're skeptical of artificial explanations while credulous toward natural ones, regardless of their relative probability. This represents exactly the kind of cognitive bias that genuine scientific methodology is designed to overcome. Genuine skepticism should be equally applied to all hypotheses, regardless of their implications for comfortable worldviews. The controversy surrounding Three Atlas may itself be part of whatever evaluation the object represents. If advanced civilizations are testing our readiness for contact, they might be specifically measuring our response to paradigm-challenging data. Do we demonstrate intellectual humility and curiosity, or do we retreat into defensive denial when confronted with uncomfortable possibilities? Our collective response to this cosmic riddle becomes data in an experiment. An experiment we didn't realize we were participating in. The observers conducting this evaluation, if they exist, are documenting not just our analytical capabilities, but our psychological maturity, our readiness to abandon anthropocentric assumptions when reality refuses to conform to them. The theories and controversies swirling around Three Atlas represent more than academic debate. They constitute our cosmic final exam answers. Whether we pass or fail, this examination may determine everything about our species' future relationship with whatever intelligence exists among the stars. The object continues its impossible journey through our solar system, glowing backwards and defying natural explanation. With each passing day, the theories multiply, the controversies intensify, and the stakes escalate. With each attempt to force unexplainable phenomena into familiar categories, whether we choose wisdom or comfort, evidence or assumption, intellectual courage or defensive denial, remains the test we're still taking. The results of that test may determine whether humanity graduates to a larger cosmic conversation, or remains classified as intellectually immature, not yet ready for the truths that await us in the universe beyond our current understanding. Stand back from the details for a moment and observe the larger pattern emerging from our cosmic visitors. First came ʻOumuamua in 2017, the cigar-shaped visitor that accelerated impossibly through our solar system, while showing none of the gas signatures that should accompany such behavior. We struggle to classify it, ultimately settling on creative explanations that strained physics. Rather than consider artificial alternatives, then our own technology taught us uncomfortable lessons. The Tesla Roadster masqueraded as an asteroid until we remembered launching it. 2020 so fooled our detection systems completely, appearing natural until detailed investigation revealed it was actually a decades-old rocket stage, exhibiting exactly the radiation pressure dynamics that Oumuamua had displayed. Now 3 Atlas arrives with anomalies so blatant that even our creative explanation mechanisms struggle to contain them. The backwards glow, the missing molecular signatures, the mathematically impossible trajectory timing, each impossibility more pronounced than anything we encountered with its predecessors. These aren't isolated incidents. They're chapters in a larger narrative that becomes coherent only when viewed as a designed progression, rather than a random occurrence. The pattern suggests an escalating difficulty, like a cosmic curriculum designed to test our intellectual evolution. Each visitor presents anomalies slightly more challenging than the last, forcing us to stretch our interpretive frameworks closer to their breaking point. Oumuamua was the introductory course, strange enough to intrigue, ambiguous enough to dismiss. Its acceleration could be rationalized through exotic sublimation physics, its unusual proportions explained through unlikely but theoretically possible formation scenarios. We could maintain a comfortable distance from paradigm-threatening interpretations, while still engaging with genuinely anomalous data. The human technology episodes served as unplanned but perfect practice problems. When we discovered that 2020 SO was actually artificial, that radiation pressure could indeed produce the acceleration signatures we'd observed, we inadvertently proved that our dismissal of artificial explanations for Oumuamua might have been premature. The lesson was subtle but clear. Artificial objects can masquerade as natural ones, even when we possess detailed knowledge of the technology involved. 3 Atlas represents the culmination of this educational sequence. Its characteristics are so impossible to reconcile with natural origins that explaining it away requires intellectual contortions that would be comical if the stakes weren't so high. The object forces a choice between increasingly improbable coincidences and the obvious alternative we've been trained to avoid considering. But here's where the pattern becomes truly unsettling. The escalating difficulty suggests intentional design. Random cosmic visitors shouldn't arrive with perfectly calibrated levels of anomaly that correspond precisely to humanity's technological and intellectual development. Yet that's exactly what we're observing. Each visitor arrives at exactly the moment we're capable of detecting and analyzing its impossibilities. The timing isn't random, it's pedagogical. Someone or something is pacing these encounters to match our readiness for each successive level of challenge. This realization transforms our entire understanding of what we've been witnessing. We're not passive observers of cosmic coincidence. We're active participants in a designed evaluation sequence. The universe isn't randomly throwing anomalies at us to see how we respond. Something is carefully orchestrating these encounters to test specific aspects of our intellectual development. The implications are staggering. We may have been under observation far longer than we've been capable of observing ourselves. Our cognitive strengths and weaknesses, our cultural biases, our institutional structures, all mapped with scientific precision by intelligences that understand human psychology better than we understand it ourselves. The evaluation appears designed to test precisely the qualities that genuine contact would require. Can we recognize intelligence when it deliberately obscures its nature? Do we possess the intellectual humility to abandon comfortable assumptions when presented with contradictory evidence? Are we capable of paradigm shifts that expand, rather than merely rearrange our understanding? These characteristics separate mature civilizations from primitive ones, genuine scientists from mere technicians, species ready for galactic citizenship from those still trapped in anthropocentric worldviews. The test measures not our computational capabilities or instrumental sophistication, but our wisdom, our readiness to engage with realities larger than our current frameworks can contain. The threading of evidence through this progression reveals a sophisticated understanding of human psychology. The evaluators know exactly how much anomaly we can tolerate before our defense mechanisms activate. They understand our tendency to explain away rather than explain toward, to dismiss rather than investigate, to protect paradigms rather than revise them. Each test case is calibrated to maximize the tension between evidence and comfort zone. ʻOumuamua provided just enough anomaly to intrigue without quite forcing paradigm revision. The human technology episodes demonstrated artificial masquerading as natural, without requiring us to acknowledge non-human intelligence. 3 Atlas pushes the boundaries to their absolute limit, forcing a choice that can no longer be avoided through creative interpretation. The progression suggests that we're approaching some form of decision point. The curriculum has been building toward a comprehensive evaluation that will determine our readiness for whatever comes next. The subtlety is ending. The anomalies are becoming undeniable. The comfortable explanations are running out of room to maneuver. This unified theory transforms Dr. Loeb's persistent advocacy for artificial explanations from career-threatening speculation into a prescient recognition of the actual pattern unfolding. His willingness to consider uncomfortable possibilities represents exactly the intellectual courage that the evaluation appears designed to identify and measure. Conversely, the mainstream astronomical community's reflexive dismissal of artificial hypotheses reveals precisely the cognitive rigidity that might disqualify a species from larger cosmic participation. The unwillingness to seriously consider evidence that challenges familiar assumptions demonstrates exactly the kind of intellectual immaturity that advanced observers would need to identify. The evaluation doesn't require us to solve impossible physics problems or demonstrate technological capabilities we don't possess. It only asks whether we can recognize intelligence when it chooses to reveal itself through subtle impossibilities rather than obvious announcements. The test measures wisdom rather than knowledge, intellectual flexibility rather than computational power, but recognition of the test's existence might itself be part of the evaluation. Are we capable of understanding that our cosmic behavior is being observed and judged? Can we acknowledge the possibility that intelligence elsewhere has been studying us far longer than we've been studying the stars? The unified theory suggests that 3 Atlas represents a culminating examination rather than another isolated anomaly. Our response will determine whether we graduate to some new level of cosmic interaction or remain classified as intellectually immature, not yet ready for direct contact with civilizations that have learned to communicate through carefully orchestrated impossibilities. The decision point is approaching with each day that the object maintains its backwards glow. Every attempt to force its characteristics into natural categories, every creative explanation requiring multiple independent miracles, every dismissal of obvious artificial alternatives all become final exam answers, answers that will determine our cosmic report card. The threads of evidence converge toward a single uncomfortable conclusion. We are being tested, we have been tested, and our performance on these examinations may determine everything about our species' future relationship with whatever community of intelligence exists among the stars. The pattern is clear, the progression is obvious, and the stakes are existential. Whether we choose to see what's actually happening or continue insisting that impossible coincidences must be natural phenomena remains the test we're still taking. The results of that test may determine whether the larger conversation ever has the opportunity to begin. The turning point has arrived. The question is whether we're finally ready to turn. The official position remains unshakable in its certainty. 3 Atlas is a comet, an unusual comet perhaps, but ultimately just another chunk of ice and rock following predictable physical laws. The anomalies are interesting academic puzzles, nothing more. Any suggestion otherwise ventures into the realm of unfounded speculation. Dr. Alan Fitzsimmons of Queen's University Belfast speaks for the establishment consensus. We have extensive data showing cometary activity consistent with natural sublimation processes. The unusual characteristics can be explained through well-understood physics. Once we account for the object's specific composition and trajectory parameters, this official narrative requires increasingly creative physics to maintain its credibility. The backwards glow becomes evidence of differential sublimation patterns caused by compositional asymmetries never before observed in cometary science. The absence of molecular signatures gets explained through an atypical ice composition involving water percentages so low they approach mathematical impossibility. Each anomaly spawns new theoretical frameworks designed specifically to accommodate that impossibility. Without acknowledging the larger pattern, the explanations multiply like academic mushrooms, each more exotic than the last, all united in their determination to avoid the obvious alternative interpretation. But alternative theories persist despite institutional resistance. Dr. A.V. Loeb's artificial probe hypothesis represents the most systematically developed challenge. His analysis treats 3 Atlas as potentially manufactured technology, rather than accreted natural material, examining its characteristics through the lens of engineering rather than geology. Under this interpretation, the backwards glow becomes evidence of electromagnetic or optical systems, operating on principles we haven't yet discovered. The trajectory timing transforms from impossible coincidence into evidence of navigation capability. The absence of molecular signatures supports rather than contradicts artificial origins, as manufactured objects wouldn't necessarily produce the chemical fingerprints we expect from sublimating ice. Loeb's hypothesis gains credibility from precedent. Human spacecraft routinely exhibit characteristics that would puzzle observers unfamiliar with our technology. Solar panels create unusual optical signatures. Attitude control systems produce inexplicable acceleration patterns, and antenna arrays generate electromagnetic anomalies that could easily be misinterpreted as natural phenomena by insufficiently advanced observers. If human technology can confuse human detection systems, as 2020 SO and the Tesla Roadster did, then technology from civilizations thousands of years more advanced might be completely invisible to our current analytical frameworks. The probe hypothesis branches into several subspecies of speculation. Conservative versions suggest reconnaissance missions gathering data about solar system composition and planetary development. More ambitious interpretations propose communication attempts, with 3 Atlas serving as a message delivery system, designed to reveal its artificial nature only to observers sophisticated enough to recognize the clues. The most speculative variants venture into the realm of cosmic archaeology, suggesting that objects like 3 Atlas represent technological artifacts from civilizations so ancient that their creators have been extinct for millions of years. Under this interpretation, we're discovering not active intelligence, but the fossilized remains of vanished technological achievements, wandering monument probes that outlasted the species that built them. Fringe theories push the boundaries of speculation into territories that make even artificial probe hypotheses seem conservative by comparison. Some researchers suggest that 3 Atlas represents a form of intelligence test or cosmic examination. deliberately designed to evaluate humanity's readiness for contact with advanced civilizations. This interpretation treats the object's anomalies as carefully calibrated challenges meant to measure our intellectual flexibility and paradigm-shifting capabilities. Others propose more ominous possibilities. The object could be a harbinger of directed contact, the advance scout for a larger intervention or investigation. Its trajectory timing and planetary encounters might represent mapping and analysis activities, preparatory to more direct forms of engagement. The darkest interpretations venture into invasion, preparatory territory, suggesting that 3 Atlas might be gathering intelligence about human technological capabilities and defensive potential. Under this reading, our dismissal of its artificial nature becomes a tactical advantage. For observers evaluating our threat assessment abilities, more exotic theories abandon conventional physics altogether. Some researchers suggest that 3 Atlas might represent technology operating on principles that transcend our current understanding of how matter and energy interact in space. The object's impossible characteristics could indicate engineering approaches that manipulate space-time itself rather than working within its constraints. These metaphysical interpretations treat 3 Atlas as evidence that intelligence advanced enough to achieve interstellar travel has also transcended the technological limitations that currently constrain human engineering. The object becomes a glimpse into forms of technology so advanced they appear magical from our current perspective. Each theoretical framework generates its own evidence base and interpretive community. Natural explanations emphasize spectroscopic data and orbital mechanics, while downplaying statistical impossibilities. Artificial hypotheses focus on anomaly patterns and precedent cases, while acknowledging gaps in technological understanding. The controversy itself reveals as much about human psychology as about astronomical phenomena. Our theoretical preferences reflect not just scientific analysis, but deep-seated assumptions about humanity's place in the universe, our uniqueness as intelligent beings, our readiness to acknowledge that we might not be alone. The debate mirrors historical controversies that preceded other major paradigm shifts. Before plate tectonics gained acceptance, geologists divided into competing camps, defending different interpretations of the same data. Before germ theory revolutionized medicine, physicians argued passionately about whether invisible microorganisms could cause disease. In each case, the resistance to paradigm-shifting explanations reflected more than scientific conservatism. It revealed a psychological investment in worldviews that provided comfort through familiarity. Acknowledging that continents could drift, that invisible organisms cause disease, or that interstellar visitors might be artificial, requires a fundamental revision of how we understand reality's basic operating principles. The 3 Atlas controversy follows this historical pattern with unsettling precision. The intensity of resistance to artificial explanations suggests that more than astronomy is at stake. We're defending an entire cosmology built on assumptions about intelligence, technology, and humanity's cosmic significance. But the mathematical realities remain inescapable regardless of our theoretical preferences. The statistical impossibilities don't disappear because we invoke creative physics to explain them away. The anomaly patterns don't become less pronounced because we assign them to natural categories. Evidence quality should determine theoretical acceptance, not psychological comfort levels. When natural explanations require multiple independent miracles, while artificial alternatives require only the existence of intelligence elsewhere in the universe, scientific methodology should favor the simpler hypothesis. Yet institutional science continues demonstrating exactly the opposite preference pattern. We're credulous toward natural explanations requiring impossible coincidences, while skeptical of artificial alternatives requiring only reasonable assumptions about technological development. This selective application of skepticism reveals cognitive bias masquerading as scientific rigor. Genuine skepticism should be equally applied to all hypotheses, regardless of their implications for comfortable worldviews. The controversy surrounding 3 Atlas may itself be part of whatever evaluation the object represents. If advanced civilizations are testing our readiness for contact, they might be specifically measuring our response to paradigm-challenging data. Do we demonstrate intellectual humility and curiosity, or do we retreat into defensive denial when confronted with uncomfortable possibilities? Our collective response to this cosmic riddle becomes data in an experiment we didn't realize we were participating in. The observers conducting this evaluation, if they exist, are documenting not just our analytical capabilities, but our psychological maturity, our readiness to abandon anthropocentric assumptions when reality refuses to conform to them. The theories and controversies swirling around 3 Atlas represent more than academic debate. They constitute our cosmic final exam answers. Whether we pass or fail, this examination may determine everything about our species' future relationship with whatever intelligence exists among the stars. The object continues its impossible journey through our solar system, glowing backwards and defying natural explanation with each passing day. The theories multiply, the controversies intensify, and the stakes escalate, with each attempt to force unexplainable phenomena into familiar categories. Whether we choose wisdom or comfort, evidence or assumption, intellectual courage or defensive denial, remains the test we're still taking. The results of that test may determine whether humanity graduates to a larger cosmic conversation or remains classified as intellectually immature, not yet ready for the truths that await us in the universe beyond our current understanding. If we are indeed being tested, what does humanity's response to 3 Atlas reveal about our species? The answer emerging from our collective behavior is deeply troubling. We are failing. Our response to the most obvious artificial visitor in human history demonstrates exactly the kind of cognitive rigidity that should disqualify a species from galactic citizenship. When presented with mathematical impossibilities masquerading as natural phenomena, we choose comfortable explanations over uncomfortable evidence. When confronted with anomalies that scream technology, we insist on invoking increasingly improbable coincidences, rather than acknowledge the obvious artificial alternative. This failure pattern reveals fundamental weaknesses in human cognition that extend far beyond astronomy. We are a species that consistently chooses familiar assumptions over paradigm-shifting evidence, institutional conformity over intellectual courage, psychological comfort over scientific truth. These same cognitive failures manifest in our approach to other existential challenges facing our civilization. Climate change presents us with overwhelming evidence, demanding fundamental changes to industrial civilization. Yet we continue seeking technological fixes that avoid uncomfortable lifestyle modifications. Artificial intelligence development proceeds with minimal safety oversight, because acknowledging genuine risk requires admitting we might be creating something beyond our control. The pattern repeats across every domain where evidence challenges comfortable assumptions. We explain away rather than explain toward. We dismiss rather than investigate. We protect familiar worldviews rather than expand toward unfamiliar possibilities. If advanced civilizations are evaluating our readiness for contact, they're documenting a species that consistently demonstrates intellectual immaturity. When confronted with paradigm-challenging realities, we show technological sophistication coupled with psychological rigidity, exactly the combination that makes a species dangerous rather than valuable as a cosmic participant. The implications extend beyond first contact scenarios into the realm of existential risk assessment. a species that cannot recognize obvious artificial intelligence when it announces itself, through carefully orchestrated impossibilities, is probably not ready to handle contact with genuinely advanced civilizations. Imagine the cultural shock that direct contact would create. If we cannot even acknowledge indirect contact when it presents itself through subtle anomalies, the psychological disruption could destabilize entire societies, built on assumptions about human uniqueness and cosmic isolation. Our cosmic evaluators, if they exist, may be protecting us from contact. Contact we're not yet mature enough to handle. The gradual escalation of anomalous visitors could represent a careful assessment of our readiness threshold, with each test case calibrated to measure specific aspects of our intellectual and psychological development. The verdict so far appears to be not yet ready, still too attached to comfortable assumptions, still too resistant to evidence that challenges familiar paradigms, still too invested in anthropocentric worldviews to handle the reality of a universe populated by intelligence. But failure on cosmic examinations doesn't just postpone contact. It reveals fundamental limitations that threaten our species' long-term survival. The same cognitive rigidity that prevents us from recognizing artificial visitors also impairs our ability to respond appropriately to other existential challenges. Consider how our response to 3 Atlas parallels our approach to asteroid impact risk. We know large impacts have caused mass extinctions throughout Earth's history. Yet, we invest minimal resources in detection and deflection systems because the threat feels too remote and abstract to motivate immediate action. We explain away rather than prepare for low-probability, high-consequence events. The same pattern appears in our approach to pandemic preparedness and nuclear war prevention and superintelligent AI development. We consistently underestimate tail risks that require uncomfortable changes to familiar systems. We prefer incremental improvements within existing frameworks over fundamental revisions that acknowledge genuinely novel threats. This cognitive pattern suggests that humanity's cosmic report card reflects broader intellectual limitations that constrain our ability to navigate an increasingly complex and dangerous universe. We are a species with remarkable technological capabilities, but persistent psychological blind spots that prevent us from using those capabilities wisely. The intelligence being measured by 3 Atlas isn't computational or instrumental. It's wisdom, the ability to recognize when fundamental assumptions need revision, the intellectual humility to acknowledge ignorance rather than defend false knowledge, the courage to consider possibilities that expand rather than merely rearrange our understanding of reality. These characteristics determine not just our readiness for cosmic citizenship, but our likelihood of surviving the challenges that technological advancement inevitably creates. Species that cannot adapt their worldviews to accommodate new realities tend to be eliminated by those realities through mechanisms that care nothing about technological sophistication. The test results from 3 Atlas suggest we are exactly such a species, technologically capable but cognitively inflexible, instrumentally powerful but intellectually immature. This combination represents perhaps the most dangerous evolutionary configuration possible. Sufficient capability to create existential risks, coupled with insufficient wisdom to manage them safely. Our cosmic observers, if they exist, may be documenting the decline phase of a civilization. A civilization that achieved impressive technological development, but failed to achieve the intellectual maturation necessary for long-term survival. They might be watching a species approach the evolutionary filter that eliminates most technological civilizations before they achieve true cosmic significance. But the test isn't over yet. 3 Atlas continues its impossible journey through our solar system, presenting us with ongoing opportunities to demonstrate intellectual growth. Each day we maintain comfortable explanations despite mounting evidence, becomes another recorded failure. But each day also offers another chance to acknowledge what the evidence actually reveals. The choice facing humanity isn't just about astronomical interpretation. It's about whether we can evolve beyond the cognitive limitations that have constrained our species. Can we learn to embrace anomalies as opportunities for paradigm expansion, rather than threats to be explained away? Can we develop the intellectual courage necessary to abandon familiar assumptions when reality refuses to conform to them? These questions determine not just our relationship with potential cosmic neighbors, but our species' fundamental viability in a universe that operates according to principles we haven't yet learned to acknowledge. The intelligence that designed 3 Atlas may be offering us exactly the kind of paradigm-expanding encounter that genuine intellectual maturation requires. Whether we choose to accept this opportunity or continue retreating into defensive denial may determine everything about our cosmic future. The test measures not just our scientific capabilities, but our wisdom, our readiness to engage with realities larger than our current frameworks can contain. The observers are still watching, still documenting our response patterns, still evaluating whether humanity demonstrates the intellectual evolution necessary for graduation into a larger cosmic community. The results of their assessment may determine whether that community ever has the opportunity to welcome us as participants, rather than classify us as subjects requiring continued observation. The implications are existential, the stakes are civilizational, and the clock continues ticking with each impossible day that 3 Atlas maintains its backward glow. Whether we pass or fail this cosmic examination may be the most important test our species ever takes. The question is whether we're finally ready to recognize we're taking it. Picture this scenario. You're sitting in your backyard on a quiet evening when you notice a stranger standing at the edge of your property. They're not threatening, not obviously dangerous, but they're clearly observing you and your family. How do you respond? Do you pretend not to see them, hoping they'll go away if ignored? Do you convince yourself they must be a neighbor or a delivery person despite their unusual behavior? Or do you acknowledge their presence and attempt some form of contact? This metaphor captures humanity's current situation with 3 Atlas and its predecessors. We have visitors in our cosmic backyard. Objects displaying characteristics so anomalous that natural explanations require miracle-level coincidences to maintain credibility. Yet our collective response resembles the first option, pretending not to see what's obviously present. But what if these visitors are waiting for us to demonstrate the intellectual courage necessary to acknowledge their presence? What if our continued insistence on natural explanations, despite mounting evidence, represents exactly the kind of cognitive failure that disqualifies a species from larger cosmic interactions? The mathematical impossibilities surrounding 3 Atlas arrival don't disappear because we invoke creative physics to explain them away. The backwards glow, the missing molecular signatures, the precisely choreographed trajectory timing. Each anomaly remains unexplained by conventional frameworks, regardless of how desperately we attempt to force them into familiar categories. At some point, intellectual honesty demands acknowledging what the evidence actually suggests, rather than what our comfortable assumptions prefer it to mean. That point may have arrived with 3 Atlas' impossible journey through our solar system. Dr. Avi Loeb's suggestion for humanity's appropriate response captures both the profundity and simplicity of our situation. Hello, welcome to our neighborhood. Peace. These words recognize the possibility that we're no longer alone, while expressing the kind of openness that genuine contact would require. But such openness demands a fundamental revision of the anthropocentric worldviews that have shaped human civilization since its beginning. We would need to abandon comfortable assumptions about our uniqueness, our technological sophistication, our cosmic significance. We would need to acknowledge that intelligence elsewhere might surpass our capabilities by margins that make our proudest achievements appear primitive by comparison. This psychological adjustment represents perhaps the greatest challenge our species has ever faced, not the technological challenge of interstellar communication, not the logistical challenge of cosmic diplomacy, but the cognitive challenge of accepting that we might be children, discovering that adults exist in the cosmic neighborhood. The metaphor is precise and unsettling. Humanity's current technological development resembles that of a precocious child who has learned to build impressive sandcastles, but remains ignorant of architecture, urban planning, and civil engineering. Our visitor might represent our first glimpse of what genuine technological maturity looks like, when coupled with million-year developmental timelines. Are we ready for such a revelation? Can we handle the ego dissolution that genuine contact would require, or would the psychological shock destabilize our civilization in ways that make contact inadvisable until we achieve greater intellectual and emotional maturity? These questions may be exactly what 3 Atlas is designed to help answer. Our response to its anomalous characteristics provides data about our readiness threshold, our cognitive flexibility, our ability to process paradigm-shifting information without retreating into defensive denial. The test continues with each day that we maintain comfortable explanations despite mounting evidence. Every creative interpretation that avoids acknowledging artificial origins, every statistical miracle invoked to preserve natural categories, every dismissal of obvious alternatives, all become part of our cosmic report card. But the examination also presents ongoing opportunities for intellectual redemption. Each moment that 3 Atlas maintains its impossible behavior offers another chance to demonstrate the kind of paradigm flexibility that genuine contact would require. We could still choose evidence over assumption, curiosity over comfort, intellectual courage over defensive conformity. The choice facing humanity isn't just about astronomical interpretation. It's about whether we can evolve beyond the cognitive limitations that have constrained our species throughout history. The same mental flexibility that genuine contact would demand is precisely what our civilization needs to navigate the other existential challenges confronting us. Climate change, artificial intelligence, development, nuclear weapons management, pandemic prevention, all require exactly the kind of paradigm-shifting thinking that recognizing 3 Atlas' true nature would demonstrate. A species capable of acknowledging obvious artificial intelligence in space might also prove capable of handling these terrestrial challenges with appropriate wisdom and foresight. Conversely, a species that continues explaining away impossible coincidences rather than accepting uncomfortable realities probably lacks the intellectual maturity necessary for long-term survival. In an increasingly complex and dangerous universe, the cosmic examination, represented by 3 Atlas, thus becomes a test of our fundamental viability as a technological civilization. Are we wise enough to recognize intelligence when it deliberately reveals itself through subtle impossibilities? Do we possess the humility to acknowledge that our current understanding might need fundamental expansion? These characteristics determine not just our readiness for cosmic citizenship, but our likelihood of surviving the challenges that technological advancement inevitably creates. The intelligence that designed our interstellar visitors may be evaluating exactly the qualities that distinguish mature civilizations from primitive ones. Species destined for cosmic significance from those approaching evolutionary termination. The results of this evaluation remain uncertain. Our institutional response has been disappointing, but individual voices like Dr. Loeb's demonstrate that human intellectual courage hasn't been entirely bureaucratized. Public fascination with these anomalous visitors suggests that popular curiosity might prove more flexible than professional paradigms. Perhaps the test is designed to identify and encourage exactly such intellectual courage, while documenting the resistance patterns that constrain it. Perhaps our cosmic evaluators are less interested in unanimous recognition than in evidence that some humans retain the cognitive flexibility necessary for productive contact. The visitor at our cosmic door continues its impossible dance through our solar system, glowing backwards and defying every natural law we thought we understood. Whether we choose to acknowledge its presence or continue pretending it must be something familiar and safe remains the test we're still taking. If the examination is already underway, are we passing? Can we demonstrate the intellectual evolution that contact would require? Do we possess the wisdom to recognize intelligence when it chooses revelation through carefully orchestrated anomaly rather than obvious announcement? The answer may determine everything about our species' cosmic future. Whether we graduate into a larger community of minds or remain classified as intellectually immature, not yet ready for the truths that await us among the stars. The observer continues observing, the test continues testing, and the clock continues ticking with each impossible day. The 3 Atlas maintains its backward glow. Prepare yourselves. Whether we recognize it or not, the next test may already be on its way, and our performance on these cosmic examinations may be the most important grades our civilization ever receives. The question that will haunt humanity until we find the courage to answer it remains: if the exam is already underway, are we finally ready to acknowledge we're taking it? The future of our species may depend on whether we can summon the intellectual honesty to say yes.